let's talk about something. I think we kind of approached this a different amount in the two periods, but I want to talk about compound interest and the fact that when we started out talking about it, we were always compounding annually, which means that the bank or whatever investment we have would only update the amount we have every year and then give us interest every year. But we started talking about the fact that usually banks, for example, would do it monthly. And so we'd like to know, let's say, what happens if I have principal P equals $1,000 and the annual interest rate R equals 5%, which we always want to make sure to say that's 0.05 really. And let's say we keep it in there for, let's say 10 years to be simple. And that's a T equals 10 years. If we compound that annually, then that's where this first version of our master formula comes in. The amount as a function of t is what we start with, and then we repeatedly multiply by r t times. And so in that case, that says a of t is going to be 1,000 times 1.05 to the t. Let's go ahead and graph that, since we can. That's funny. Looks like a straight line. But I thought the whole point was it's not a straight line. Well, that's because this is only going out 5 years, and in fact it's going 5 years into the past. Let's go ahead and graph that from 0 to 45, which is what we were doing in class in terms of the numbers we were looking at. Now we can see, okay, that gets up to about 9,000, which is a value that makes sense with what we were doing in class. Starts out with 1,000. It starts out growing, and you can see the rate of growth gets steeper and steeper and steeper, and that's a big difference from if it just went out linearly, which would be like this, and gets up to about 3,000. So let's look at what happens if we compound more than annually. Let's suppose it's compounded monthly. Then what's going to happen? If, well, t equals 0, then amount is just $1,000. If t, I keep doing that wrong, t equals 1/12, that's 1 month, but I'm always going to express it in units of years. That's going to help a lot. If t equals 1/12, then what are they going to do? They're going to take this 5%, and let's write this right down, right here. The monthly interest rate is are just going to take that and divide it by 12. And so that's going to be 0.05 over 12, which is 0.0041667. 6 repeating, really. Okay. So the amount after 1/12 is going to be that 1,000, and they're going to give me this much interest. We know that that's something we want to do by adding, or sorry, multiplying by 1 plus r over 12, or that's let's just put it here, equals 1,000 times 1.04167. And so that's going to be $1,004.17. That doesn't sound like a lot, but remember that was after only 1 month of just sitting around and watching your money. If t equals 2/12, they're going to do that process twice. They're going to take that number, which was already multiplied once by 1 plus r over 12, and they're going to multiply it by that again. So it's going to be r over 12 squared. And so that's 1,000 times 1.0041667 squared. I'll have it calculate that for me. 1,008.4. Let's put it up here. 1,008.40 cents. Okay, well, let's not step through all the months. Let's try to go to 1 year, and then we'll try to go to 10 years. Sorry, okay. So that's going to be 1,000, and they're going to do this process of just giving me a little bit more money, but they're going to do it 12 times. And let's compare that. Let's see. If they just compounded annually for 1 year on 5%, I'm going to end up with $1,050. That was one of the very first calculations we did. And this is going to be, let's see, 1,051.2. I'll put it up here. So 1,051.20 cents. So we get an extra $1.20 out of this. Well, it's not huge, but it's something. What about t equals 10? 10 years. Then I'm going to start with 1,000. They're going to give me this measly little multiplier, 1 plus r over 12, but this is going to do it 120 times. And that's going to be 1,000 times 1.04167 to the 1/20th, 1647. And apparently no cents. Okay. So that's the idea here is that you take your interest rate, you divide it by 12 because it's happening 12, you only get 1/12 the interest each time, but this number gets multiplied by 12. And so instead of doing it 10 times, you do it 120 times. So let's look at the master formula. If there are n compoundings, that's another little variable we have here, per year, we have, and this is in the book as well, you start with your principal. The growth factor per compounding period is reduced. It's only 1 plus r over n, but you're going to have, instead of just t times compounded, you're going to have n times t compounded. So like here, the 120 was a 12 times 10. The 12 being n goes into these two places. So one really interesting thing to do is to think about, well, this gave me a little bit more money. Let's compare this. Well, yeah, what we want to do is compare that to what happened with just annual compounding, and I have that on another sheet in a second. And it's going to be more money. Okay, so let's see. I have this pre-done, so it doesn't take forever. So here, starting with $1,000, 5% interest, t equals 10, and what happens with different compounding periods? If it's monthly, that's where the 1647. I guess that calculated a little more exactly was 0.01. So you get 1647.01. If you were just doing it annually, if you just compounded 10 times, but each time they gave you the full 5%, then you get only 1628.89. So you get almost $20 more. In between, if you did it quarterly, once every 3 months, then you get 1643.62. Well, who says it has to be monthly? What about daily? We could do that. That's not hard for a computerized banking system to do. Gives you another $1.65. So it keeps going up, and then the question is, does it just keep going up and up and up? Suppose they compounded it every second or every millisecond. Would I just get a huge amount of money? Well, the answer is no. You just get a tiny bit more money. If you do it every second, roughly, it's about 32 million times a year, you get just an extra 6 cents. And if we did it every millisecond, it would be basically, you wouldn't get any more money to speak of. What's interesting about that is that we're going to, instead of saying, oh, then we won't bother with this kind of idea, it actually turns out to be very elegant if we actually imagine that every one of our accounts updates every second or every millisecond. Because then we don't really have to bother about, oh, exactly how often is it updating. And if it's really only doing it every month, well, you know what? It's not that different. It's a good approximation. And it actually is simple because it takes out this n from the whole story. And so we're going to be led to that, and we're going to do some more investigations in class about that. But that's a good place to stop this video.